In this lesson, you're going to learn how to solve radical equations. Now, if you're trying to find the x-intercepts of a radical function, you end up solving a radical equation. You let y be 0, and then you're going to solve, and algebraically, that's how you're going to get the x-intercepts. Okay, so if you want to know where does it cross, you've got to be able to solve a radical equation. Let's begin with an example. In this equation, we are trying to solve a square root equation. So in general, what you want to do is try to isolate the radical portion. So I'm going to get the square root by itself. So I'll begin by adding 2 to both sides, which gives me 2x plus 2 is equal to the square root of 100 minus 12x. Now that the square root is isolated, to get rid of it, I do the inverse, which would be square. So I'm going to square both sides, and this is where it gets tricky because that means that I'm squaring a binomial, and when I square a binomial, I get a trinomial. So I need to square this, which would produce 4x squared. I'd have plus 4x and plus 4x, or plus 8x for the product of my outer and inner, and then plus 4 equals 100 minus 12x. Okay, now it's a quadratic equation. I am going to bring everything to the left and putting this in standard form. So I'm going to add 12x to both sides, and I will subtract 100, which produces 4x squared plus 20x minus 96 equals 100. All right, now that it's quadratic, I've got several choices for solving this. I can try to factor it and apply the zero product property. If that fails, I could go to the quadratic formula. I'm going to try factoring, and I'm going to begin by factoring out a GCF. Looks to me like I can pull a 4 out of this, which would produce x squared plus 5x minus 24. And then I'm going to try to find factors of negative 24 that would add to 5. And I'm thinking 8 and 3. So I'm going to do x plus 8 times x minus 3. That would multiply to negative 24, and it would add to 5. So then I apply the zero product property, which says x plus 8 equals 0, or x minus 3 equals 0. So I solve each of these, which produces x equals negative 8, or x equals 3. Now it appears as though we have 2 solutions, but we need to be careful here. I mean, if you think about what does a square root function look like, and we're looking for where it crosses the x-axis, it is a function that typically looks something like this. There is only typically with a square root function going to be a maximum of one place that it crosses the x-axis. So one of the things you've got to look for is something known as extraneous solutions, which is something that looks like an answer, but when you plug it back in, it does not satisfy your original equation. So as much as sometimes students think this is a hassle, you have to go back to the original and check it. So I'm going to check negative 8. I'm going to do 2 times negative 8, and I'm checking, does that equal the square root of 100 minus 12 times negative 8, and then subtract 2. And I would get the square root of 196, which is 14. 14 minus 2 is 12. And right here I have an issue. Negative 16 does not equal 12. So that's telling me that negative 8 is not a solution. I still need to check to see if 3 is. So I would get 6 is equal to, let's see, have 100 minus 36 would be the square root of 64. Minus 2, the square root of 64 is 8, minus 2 is 6, 6 equals 6. So this one works. So my only solution is x equals 3. So after you solve these, you've got to check to see if you have extraneous solutions, which happens anytime that you are multiplying both sides by a variable by x, or it happens when you're raising both sides to the second power or the third power. Okay, in our second example, again, I'm going to try to get the radical portion by itself. I have the cube root part I'm going to try to isolate this portion. So I'm going to begin by subtracting 14 from each side, which would give me 36 on the right, and I'd have the cube root of x minus 5 squared is equal to 36. Now that that's isolated, I am going to cube both sides. I'm doing the inverse. Let's see, 36 cubed is going to be a large value. That is 46,656. And I'd be left with just the radicand, which is x minus 5 squared. Okay, so from this point, I probably have two courses of action. I could square this x minus 5 and make that x squared minus 10x plus 25. Then subtract the 46,000 from both sides and try to factor that. But I may have a different course of action. So I have the left side is squared. If I can take the square root of both sides, which is completely legal here, and I think I'm getting lucky, the square root of 46,656 is a perfect square. Now, the moment I take the square root of both sides with an equation, I need to remember to squeeze in plus or minus, that there are two answers. So this would be plus or minus 216, and now it's not so bad. So I have x minus 5 equals this, which actually is telling you that there are two problems here. One of them is x minus 5 equals negative 216. The other one is x minus 5 equals positive 216. So I'm just going to add 5 to both sides, and I get x equals negative 211 or x equals 221. Now, I do need to check both of these to see if either one is an extraneous solution. So as I check this, I get negative 216. I square that, and then the cube root gives me, let's see, this is 36 plus 14 equals 50. 50 equals 50. So negative 211 works. And then I'm going to try 221. And I believe this one's going to work as well, because I'm going to have positive 216 squared, which will also work. All right, I don't even need to go any further on this. I'm going to get 50 equals 50. So this time there are no extraneous roots. I have two valid solutions. Belief number 3 is probably algebraically the most challenging of the equations we've done, and it's because there's a radicand on both the left and the right. My only course of action that I can see here would be to square both sides. Squaring on the left is easy. That produces just the radicand of x minus 2. The right side is a little bit trickier because what we're actually doing is multiplying two binomials together, and I'm just going to expand it to help your eyes see what it is I'm doing. And I'm just going to do the product of the first and the outside. So that's 5 times 5 is 25. And then 5 times negative the square root of 15 minus x would be minus 5 times the square root of 15 minus x. I'm going to switch to green now. We are going to now distribute this radicand to both things in the second binomial. So this would be minus 5 times the radicand of 15 minus x. And then I'm going to do this radicand times this radicand. So first of all, negative times a negative is a positive. So I'm going to have plus. Just when it would be like squaring that radicand, so I just get what's left, the 15 minus x. Okay, so I'm going to clean this up now. I'm going to have 25 plus 15 would be 40. I have, in the middle here, I have minus 10 times the radicand 15 minus x, and I still have a minus x. On the right, I've got x minus 2. Okay, so now what? I haven't completely gotten rid of all my radicands, but I'm going to start combining like terms. So I'm going to add x to both sides, and I'm going to subtract 40, which is going to give me 2x minus 42 is equal to negative 10 times the square root of 15 minus x. Okay, so I have the radicand on the right isolated, so what I'm going to do is I'm now going to square both sides once again. So the second time I'm squaring both sides. And this would produce on the right, this is all held by multiplication, so it's like I'm squaring negative 100 and I'm squaring the radicand would produce positive 100 times 15 minus x. On the left side, I have actually, I'll just expand it to show you 2x minus 42 times 2x minus 42. I'm going to quickly do this, would give me 4x squared. I'd have minus 84x minus another 84x would be minus 168x, and negative 42 times negative 42 is positive 1,764. All right, definitely getting closer. I'm going to distribute on the right. Let me just give myself some more space. Would be 1,500 minus 100x. On the left, just recopying this. And I'm going to combine all my like terms. So I would have 4x squared. I'm going to add 100x to both sides, gives me minus 68x. And then subtract 1,500 would be plus 264 equals 0. So now all of that leads me down to a quadratic equation, and I'm hoping that it's factorable. So I'm going to start by factoring out a 4, which gives me x squared minus 17x, make that an x, plus 264 divided by 4 is 66, is equal to 0. All right, and now I'm going to factor this remaining trinomial. Factors of 66 that add to negative 17. Let's see, I'm hoping 6 and 11. Yep, 6 and 11 are going to work here. So I then, by the zero product property, need to set these factors both equal to 0. So I get x equals 6 or x equals 11. But there's a really good chance that one of these is extraneous. So I'm going to plug in 6 here and evaluate the left and the right side. So I'd have 6 minus 2, which is 4. Square root of 4 is 2. On the right, I have 15 minus 6 would be 9. Square root of 9 is 3. 5 minus 3 is 2. Okay, so 6 works. So now I'm going to plug in 11 and check and see if 11 works. I'll switch here to red to help your eyes. All right, so 11 minus 2 is 9. Square root of 9 is 3. On the right, let's see, 15 minus 11 here is 4. Square root of 4 is 2. So I'd have 5 minus 2 is 3. So this one works. So both of my solutions are good. There's nothing extraneous.